we are going to analyze the parallel connection between diodes. So first, let's go to the simulation. We are in Multisim Live, so I selected the diode. I copy the diode multiple times, let's say just 4 times. Now I'm going to the source, DC voltage source. I place just there, use a resistor. It's important to use a limiting resistor because if not, you're going to burn your diodes. Remember, it's important. Now let's take a switch. I want to do a circuit control with a switch. So let's take this resistor up, connect it to the switch. I'm connecting the switch to the diode, to the other diode, the other diode. So as you can see, I have a parallel connection. They share the same 2 nodes. Now I put my connection to the ground and completely connect all my diodes. Now I will set up my ground, just there, and the voltage. I want to know what's the voltage at that terminal. And the current. So I'm selecting all blue diodes. They are all the same. This simulation has all the diodes the same. Now let's see, run the simulation. You see that when I close the circuit, the blue diodes light up. When I open, they just turn off. Pay attention to the voltage. Now I place probes for potential difference on top of each diode. So this green probe is measuring the potential difference across the source, and the other gray probes are measuring the potential difference across each diode. You can see that when I close the circuit, all diodes have the same potential difference because they are connected in parallel. So the source is 5 volts, but every time that I close the circuit, each diode has the same potential difference because they are in parallel. Now let's go to put this into practice and to actually measure with the multimeter. Let's go. So let's measure the DC voltage source. We have around 4.67 volts. I am going to connect the DC source to the breadboard, negative here and positive red here. Now I'm going to connect this resistor, the limiting resistor, to the negative and to any position on the breadboard. Let's connect the button to receive a jumping wire from the ground. Jumping wire from the ground. Here. Now this cable here is the power source. And now I'm going to connect the diodes. So the long leg goes to the plus and the short leg goes to the minus. Long to the plus, short to the minus. Long to the plus, short to the minus, and long to the plus, short to the minus. Now let's see if it works. I'm going to push the button, and yes, it works. So everything in this connection is in parallel. The diodes are in parallel, and they are in series with the limiting resistor. So let's see what's the voltage across the diodes. So now I am going to test the voltage across the diodes. The black cable is going to be here at negative, and the red cable is going to the positive. My red probe goes like this, and I am going to hook it to the red probe of the multimeter, and my black probe is the negative ground, is hooked to the ground in the multimeter. Right now it's off. I am going to turn on to see what happens. When the diodes are on, there is a 2.4 volts across all the diodes because they are in parallel. So let's see, right now it's like 0. When they're on, we see that they have 2.4 volts across all the diodes. So let's do it again. 2.4 volts. We know that this is a parallel connection, so all the diodes have the same potential difference across them. Let's measure at the other side, and you'll see that they have the same potential difference. I'm going to take these probes and measure at the other side of the circuit. They are the same nodes. Let's see. 2.4 volts. Again, you see, it's the same. They have the same potential difference across. Now let's see what happens if I try to use different diodes, different colors. So let's change this one for a red diode. Let's change this for a green diode. And let's change this one for a yellow diode. What do you think is going to happen? It's going to be the same? Are they all going to bright with the same intensity? So let's see. Wow, only this diode is working. The other diodes are just dim, completely dim. We have to measure why this is happening. We want to know. So let's take this probe to the positive and this probe to the negative. I want to measure what's happening across the junctions. So let's see. When the diode, the red diode, is brightening up, we only get 1.7 volts across all the junctions. Only 1.7 volts. The other ones are not working. Let's see what happens if I take out this red diode. You see, only the yellow one is working. But now we get a higher potential, it's 1.8 almost. It is a little bit higher, 1.8. Let's take the yellow diode out. You see, now the green one is brightening up, but the blue one is not working. We have 2.1, it's a higher potential. You see, now the green one is working, but the blue one is dim. Now let's take the green diode out, and the blue is working. The blue diode is lighting up, and we have 2.5 volts. We have a higher potential than we had before. So the reason why when we had all the diodes connected from different colors is because each color has a different voltage barrier. So the diode that has the lower barrier, the red one, is going to light up first. When I had all the diodes connected in parallel with different colors, only one was brighting up. It's because the parallel connection needs to be at the same potential. So because of the physics, and the diode that has the least potential barrier is going to light up first, and they all are going to share the same potential. So you see that the red one has a lower one, is the lowest, is 1.7. It's going to bright up at 1.7, so the whole circuit is going to be at 1.7. That means that the blue one is not going to light up, because the blue one needs, we're going to see, the blue one needs, you see that the blue one is working with a 2.5 volts to break the potential barrier. So that's why if we use the red one, it is going to light up. But that means that the parallel connection is going to set up for a lower potential of 1.7. So that's the reason. This comes from the physics, from the potential barriers of the diodes. We have a table with different characteristics according to each LED color and composition. We also have the forward voltage versus current graph. The forward voltage is what we have to apply across the LED in order to conduce current. From the graph, we can see that the red LED needs a lower forward voltage than the yellow, and the yellow needs a lower forward voltage than the green, and the blue needs the highest forward voltage to bright up. That's why when they were all connected in parallel, the red one bright up first and the other ones were dim, because the whole connection was set up for 1.7. So the other LEDs didn't have enough forward voltage to bright up. Okay guys, I hope that this explanation was useful and interesting. Remember to share, comment, like, and share with your friends. I'll see you in the next video.